Now, the next topic of this course is related to the arithmetic addition in the binary system. I want to explain you that how we can add two binary numbers with together. So the topic is arithmetic addition. So I want to find an algorithm to extend this algorithm into the binary systems. Actually, you are familiar with adding two numbers in the decimal systems, but I want to do it in the binary system. Suppose that I have two numbers in the base of R, something like that. I want to write two numbers, A0, A1, A2, A3, a 4-bit number which is written in the base R, and B0, B1, B2, B3, again in the base of R. I want to add these two. We know that if we add these two numbers, we will have this C0, for example, C1, C2, C3, and maybe extra digits at the end of this addition. So in the digital system, we call the last digit as carry. This is called the carry. Carry is the extra digit that can be produced when we do the arithmetic operation. So how can I find this C0 or this C1 or the other one? If I want to write a actually algorithm, I can say that if C0, one of these C0, C1, C2, C3 is greater or equal than R, so we can say that we have to subtract one CI. So what is the CI? CI generally can be written as AI plus BI. Like this one, for example, 749 to the actually 523 in the base of 10. Suppose that R is equal to 10. What should I do? I add the 9 plus 3. It means that I have to add A0 plus B0. Now, what's happening when the addition of these two numbers are greater than 10? CI is greater than 10. What should I do? I say that CI is equal to CI minus R. So I say that this is 12. 10 minus 12 is 2. And 1 is actually added to the next digit. So I subtract the R from the CR and add 1 to the next digit, like this one. So if CI is less than R, something like that. Look at here, 1 plus 4 is 5, plus 2 is 7. Because 7 is less than 10, directly write it. If CI is less than R, CI is equal to CI. This is the algorithm that I can apply it for all of the different R-based numbers in the addition. For example, suppose that I have two numbers and want to add two numbers with together in the binary system. Look at here. Suppose that I have something like that. Now r is equal to 2. Now I have 1 0 1 1 0 1 and 1 1 1 0 0 1. I want to add these two numbers in the base of 2. So we say that 1 plus 1. So 1 plus 1 is equal to 2, greater and equal to 2 are. What should I do? I have to 2 minus 2, which is equal to 0. Write 0 here and 1 1 here. Like the algorithm that we talked about that. Now again, 1 plus 0 is 1 plus 1 again is 2. 2 is greater than 2. I have to write 1 0 1 1 here. 1 plus 1 is 2 plus 1 is 3. 3 is greater than 1. 3 minus 2 is equal to 1. Write 1 here, another 1 here. 1 plus 1 plus 0 again is 0 1 and 1 1 is 1. 1 1 is 0 1. Or we can say that 2 in the binary is equal to 1 0. Now 1 2 3 4 5 6, and here we have 1 2 3 4 5 6 7. What does it mean? It means that this bit is called as carry. It's called as carry. Similarly, for all of the others, like if I suppose that r is equal to 8, when r is equal to 8 and I have 4 5 7 plus 2 0 3, for example. But suppose that this is not 10 base, this is 8 base. 7 plus 3 is 10. 10 is greater than 8. It means that I have to write 10 minus 8, which is equal to 2. I write 2 here. 1 goes to the next digit. 1 plus 5, 6 plus 0 is 6. 6 is less than 8. It means that directly write the 6. 2 plus 4 plus 2 is equal to 6, and I have to write 6 here. Now this is the addition of two numbers in the case of actually octal. Same thing happens for the hexadecimal. Now what about the subtraction? What about the actually subtraction, arithmetic subtraction? So what about the arithmetic subtraction? How we can subtract two numbers with together? Similarly, if I suppose that I have A0, A1, A2, A3, B0, B1, B2, and B3, and want to subtract these two numbers with together, again we will have C0, C1, C2, and C3. Okay, so now same as the previous one, I want to talk about this concept that how C0, C1, C2 is obtained. We say that if AI is greater or equal to dBi, here, suppose that I have again something like that, 749 minus 382 in the base of r is equal to 10. When AI, this is AI, A0, this is B0, is greater than BI, we say that CI is equal to AI minus BI. So I want to find the CI. So I can write it, for example, here is equal to 7. Now, if AI is less than BI, like this one, 4 is AI, 8 is BI. How can I find this one? We say that we borrow 1R from AI plus 1, for example, from here, and add 1R to the next one. Here get these 6, and this one will be 14. Then we do the subtraction. Now I write the same thing. I say that if AI is less than BI, borrow 1R from AI plus 1 and add to AI. So in this case, CI is equal to AI plus R minus BI. Look at here, add AI to the R, then subtract with the BI. And then repeat the process. Now look at here, how can I do it in the case of the binary? Suppose that I have something like that. Again, R is equal to 2. And I have something like that. 1, 1, 0, 1, 0, 1, and 1, 1, 1, 1, 1. I want to subtract these two numbers together. First of all, because in the second number bit is less than the first one, we can add the 0 here, it doesn't matter. But I want to show you that the both of the numbers of bits for two numbers has to be the same. So again, same thing happens. 1 minus 1, 0. 0 minus 1, I cannot do it. I have to borrow 1R from the next one. So this will get to 0, and this will be 2, same as the decimal number. Now 2 minus 1, 1. 0 minus 1, I cannot. So I have to borrow from the next one. This is 0, I cannot borrow from here. So I have to borrow from the next one. So this will get to the 0. This will be equal to 2. Again, I have to borrow 1, 2 from this one to the next one. Now we'll get 1. Now this will be 2. 2 minus 1, 1. 1 minus 1, 0. 0 minus 1, I cannot do it. This is equal to 0. This will be equal to 2. 2 minus 1, 1. 0 minus 0, 0. Now I could find the subtraction in the form of the binary. Same thing happens for the other one. In the case of the actually octal, or in the case of the hexadecimal, same thing happens, and you can find all of them in this form. But the important thing is the subtraction in the binary. Now you can see that the calculating the subtraction in the form of these normal subtraction that we have learned in the actually in the primary school, it is difficult for us, and also for the digital systems, to calculate this subtraction using this form, because has to borrow from the next one, add to the other one, and also do the subtraction and something like that. So how we can actually do this subtraction without doing this process? without applying this algorithm that I have written here and you can see. So, because as I said, this algorithm is difficult for the digital system to apply to themselves. To actually subtract two numbers, we in the digital system, we prefer to do this one instead of this algorithm. Suppose that we say that if we have m minus n, instead of doing this subtraction, do this addition, m plus minus n. We know that these two are the same. So we say that if I could find the negative of the n, we call this one as minuend and this one as subtrahend. If we find the negative of the subtrahend and add the negative of subtrahend with the minuend, I can find this subtraction. So the question is that how can I find the negative of a number in a digital system or in the binary systems? Let's look at here.